Hello, welcome to Marine Tech. Today, we are diving into the topic of starting air system and let's understand basic working principle. Let's break down the basics of how compressed air is harnessed to bring a massive marine engine to life. Firstly, let's understand a simplified overview of the system. Air is compressed to a high pressure by the air compressor. The compressed air then passes through non-return valves and is then stored in air receivers for later use. From here the air is distributed to engine cylinder through various components including master air starting valve, distributor and starting air valve. When the engine needs to be started, a signal triggers the release of compressed air to the engine cylinders. And the high-pressure air forces the pistons to move, cranking the engine and initiating combustion. Now let's take a closer look at the components. Air compressors. These high-pressure multi-stage compressors suck in atmospheric air and compress it to a significantly higher pressure, typically around 30 bar. In multi-stage compressors, intercoolers are used to cool the compressed air between stages, increasing efficiency and reducing the final temperature. The compressed air is then stored in large, high-pressure air receivers. These receivers ensure a continuous supply of air, even during prolonged periods of engine operation. The number of starts required for air receivers on a main engine is specified by SOLAS. For reversible engines, the total air receiver capacity must be sufficient to provide at least 12 consecutive starts without replenishment, alternating between a head and a stern. And for non-reversible engines, the total air receiver capacity must be sufficient to provide at least 6 consecutive starts without replenishment. Now let's understand important functions of automatic air start valve. Main start air supply and shutoff controls the flow of main start air into the main start air line, acting as both a supply valve and a shutoff valve. Exhaust gas backflow prevention functions as a non-return valve to prevent the backflow of exhaust gas in case of a leaky starting air valve. Flame prevention incorporates a flame trap to mitigate the risk of flame propagation. Automatic shutoff automatically terminates the starting air supply when the engine transitions to fuel operation or is in the stopped state. An air starting valve is installed at the center of each cylinder head, regulating the flow of 30 bar air to the combustion chamber. An air supply pipe connects the cylinder head to the air manifold. The pipe's opening is located within the cylinder head, adjacent to the air starting valve. To safeguard the air manifold from potential hot gas exposure and backfires originating from the cylinder, a flame arrestor is incorporated into the air supply pipe near the cylinder head. Main starting air, pressurized to approximately 30 bar, enters the chamber above the valve and seeps through circumferential ports in the valve body. However, due to the combined force of the spring pressure and the balanced piston area, this 30 bar air is insufficient to open the valve. To initiate opening, the air distributor supplies 30 bar air to the top of the valve body. This additional pressure overcomes the spring force, allowing the valve to open. High-pressure air then flows into the combustion chamber, driving the piston downward. Once the air signal from the air distributor is released, the pressure on top of the valve is reduced, enabling the spring to close the valve. Now let's understand the sequence. Suppose a start signal is given. The system will first check the status of the turning gear interlock. If the turning gear is engaged, the start signal will be paused. This prevents accidental starting while the engine is being turned by the turning gear. If the turning gear is disengaged, the system will send a start signal to the distributor and master air starting valve. The master air starting valve will then open, allowing compressed air to flow into the starting manifold, and air will move to each cylinder starting air valve and wait for pilot air from distributor. The distributor has a negatively profiled cam, controls the timing of air distribution to the individual cylinder units. As the cam rotates, it sequentially aligns the pilot valves with the cam's negative slots. This alignment allows compressed air from the starting manifold to pass through the pilot valve and act on the top side of the operating piston in the air starting valve. The increased pressure on the top side of the piston overcomes the balance of the valve, causing it to open. This allows compressed air to flow into the cylinder unit, initiating the engine's start cycle. By following this sequence, the starting air system ensures that the engine is started only under safe conditions and with precise timing. Thanks for watching the video till end. Do comment for any query and also any other topics you want to get covered. Do like and share the video.